All right, Ni men hao. I am Charles Nutter. Charlie to my friends, feel free to call me that. You're all my Ruby friends here. I'm a JVM language at Red Hat. We are always hiring. If anybody wants to work full-time on open source, I can hook you up with that. I've been working on JVM stuff for about 20 some years, and about 12 years now working full-time on JRuby, almost 13 years now. I'm thrilled to be back in Taiwan. I haven't been here in a couple of years. Who likes beer? All right. I travel for two things. I travel for technical reasons, to talk at Ruby and Java conferences, and to find new beers. And what I have been doing lately is bringing some with me from home. So I have a couple of these American beers. It's Omni Brewing. It's from my home city of Minneapolis. I brought a double New England IPA that I will have out to share at the party tonight. So anybody can get a little sip of it and see what you think, okay? I mentioned I am from Red Hat, which is now also IBM. So far, we're not seeing a whole lot of impact on how Red Hat works. The official line is that Red Hat will remain Red Hat, and we will just work with IBM on cloud stuff and other things. So thanks very much for Red Hat to send me out here and to keep sponsoring our project. All right, the topic at hand. Let's talk a little bit about JRuby. So how many people have used JRuby before? Couple. How many people know what JRuby is? All right, so it's about half the room that knows what it is generally. So what we always tell people is that JRuby is a Ruby implementation first. Our primary goal is to be as much a drop-in replacement for CRuby as possible. All the Ruby code should work the same way. The libraries generally should work. Pure Ruby libraries should just run right. There are a few things that we can't support, like forking, which is not supported on the JVM, the Java platform. We don't support Ruby's C extensions, but we have our own extension API, and many of the existing extensions out there already support JRuby. So yes, as you get a chance, if it doesn't run like you would expect, if it doesn't run like CRuby, let me know, let us know, file an issue, and we'll help figure out what's wrong there. But we're also, of course, a JVM language, which means we get the benefit of being on this amazing platform, the JVM. So as Mott said, there's decades, maybe hundreds of man-years of hours, man-years of work put into the JVM to optimize it, to write good garbage collectors, to make it work across all these different platforms. And we just kind of get the benefit of that. We get a fast platform with a good JIT, with good garbage collection and parallel threads, real concurrency, and all of the tools and libraries that come with being on that platform. So here's a little example of Ruby code calling into JVM libraries. This is just using swing to create a little window, stick a button on it that says click me. Then we add an action listener to that window so that when we click on it, it'll do something. That's going to bring up a little message dialog. Down at the bottom, we get it all ready to go. We add the button to the frame. We set the frame's default operation to shut the whole application down, and we show the app. And we get something like this. Very easy, very much like Ruby code. And once you've got the classes imported in and you've pulled in the Java library you want to use, it looks pretty much like writing Ruby code. Now, there's a lot more fun stuff we can do with this. There's a Minecraft plugin API called Plugin, that Tom wrote, the friend of ours, the other JRuby guy. And so this is all the Ruby code that's required to do this little plugin for Minecraft. Here, he's basically changing the number of chickens that hatch out of each egg from, I think it's like a random one or two, to 120 chickens. And funny story, he actually tested this out on a Minecraft world that he actually was working on and intended to keep. And after creating several 100,000 chickens, the world was completely unusable. So he tried to send a bunch of wolves in to eat the chickens, and that just made it worse, and he had to throw the whole world away. But yes, again, so this is written in Ruby, and it hooks up with the Java version of Minecraft, and you can write Minecraft plugins. Now getting more serious, I mentioned that we have real parallel threads, real concurrency. So when you run JRuby on, for example, in this case, an 8-core system, you will be able to see all 8 of those cores lit up 100%. It will use up all of the power of your machine and not use any more memory like you would have to do with CRuby, spinning up extra processes. I've mentioned the JVM tools we have. This is one called Visual VM. On the left side there, you can see that it's tracking CPU usage, the general size of the garbage collected heap, how many threads are running. On the right side is a plugin called Visual GC, and this is showing a live view of how the JVM garbage collector is working. What's in the young generation, what's in the old generation, how it's cleaning up objects as you go. And this is all open source, all free tools, and there's dozens of things like this that all work great with JRuby. So where do we stand on the JRuby roadmap at this point? Right now, 9.2.7 is the current release. We are compatible with Ruby 2.5. We have started work on Ruby 2.6, but we're kind of debating whether we want to do 2.6 or just skip to 2.7 later in the year. Generally, this is a matter of resources. Keeping up with each version of Ruby takes a lot of work. Revving JRuby, a major rev for the new Ruby compatibility, is a big deal. So we're thinking maybe that JRuby 9.3, the next major release of JRuby, will be Ruby 2.7 compatible. How many people have moved to Ruby 2.6 for apps? A couple, yeah. So it's not, and those of you that have moved may or may not be using Ruby 2.6 features. So we're probably going to skip over it since we're about halfway through the year. We'll just start planning to go straight to Ruby 2.7. But we do have a checklist for Ruby 2.6 issues. As we get towards the end of the year and Ruby 2.7 is finalized, we'll have a similar checklist and get everything into 9.3 next year. Other recent items that we've been working on. I did a big chunk of work to support refinements properly. We did not have 100% support for them. Then people started using them in Rails and using them in other libraries. We needed to catch up. So I rewrote how all of the method lookup and how refinements work internally. It's pretty darn close to 100% passing all of the different refinement tests out there. Anything that uses refinements should be good. Let us know if you run into something, and maybe it's one of these smaller edge cases that aren't quite there yet. I am still in the process of rewriting the whole load and require subsystem. We had kind of fallen behind on the logic involved. We didn't have some of the same caching, so there were issues with performance. And there were subtle little bugs in how autoload worked that actually would break the Zeitwerk code loader that's being used in Rails 6. But this is almost done now. Zeitwerk is 100%, and most of the other autoload and require and load tests are 99% passing at this point. Should have that all 100% in the next couple weeks. We've also been trying to explore options for doing better with enumerators and fibers. Lots of use, for example, the async and Falcon server that we have, we're going to be hearing a keynote about later today. JVM doesn't have support for real fibers like are in CRuby. So we're faking it right now with threads, but there is a project in the OpenJDK in the JVM world to add native coroutines, native fibers to the platform. So probably after RailsConf is done, we're starting to work on supporting this right now. It's just really kind of been pushed back by doing the load require work for the moment. All right, so what about performance? We got concurrency, we've got all the tools, we got all the JVM libraries. Does JRuby perform well in comparison to CRuby? Well, a little review here about how JRuby works, kind of similar to the CRuby implementation, except for everything on that right side. So we take our Ruby source in, we parse those and compile them into our internal instruction set, very similar to how CRuby compiles it to YARV instructions. Then we have our own interpreter for that instruction set, and this is what a lot of code will run in early in the application. Eventually, once we see that code is getting hot, it's being used a lot, that will get turned into JVM bytecode. And then after that, the JVM runs it. It does the same sort of process, interpreting the bytecode for a while, profiling it, and then turning it into native code. JRuby was really the first native JIT for Ruby code because we just let the JVM do it for us. So I have microbenchmarks, and then we're going to get into some more serious ones. Of course, microbenchmarks are not particularly useful to users, but they are useful to us as far as optimizing the runtime. And we've won these microbenchmarks for years, so it's not super meaningful, but it helps us see if we're improving over time. They are fun to show off, though, and they're maybe not practical, but they're nice to show what we're able to do with JRuby. It's easier to isolate specific things. The benchmark I'll show is heavy on mathematics. So doing math operations is what we want to test and make sure runs fast. And it also is a quick way to check out what sort of relative performance you might see. So this is just a Mandelbrot generator, a fractal generator. Not too much to this code. It's pretty standard implementation, but a lot of numbers, a lot of floating point math, and it's all written in Ruby. And then it just prints out a Mandelbrot set to the command line. So what does this look like on JRuby? Well, here is CRuby 2.5 was what I measured the first time here. 3.57 seconds per iteration of this benchmark. The JIT was helping a little bit last time I tried. This may be improving in Ruby 2.7, but didn't have a huge impact on the performance of this application, or the performance of this little benchmark. JRuby just running normally, a little bit faster than CRuby, so looking pretty good. This is just pretty much what you would run if you had JRuby at the command line, didn't pass any other special flags. But we have a way that you can turn on a JVM feature called Invoke Dynamic. Invoke Dynamic makes a huge difference. That starts to improve performance 2-3 times over regular JRuby, 3 or 4 times faster than CRuby in some cases. And now, of course, JVM always is moving forward, and there's new optimizations, there's new garbage collectors, there's new JIT compilers. One of the more interesting ones is the Graal JIT, which is now becoming popular in OpenJDK world. Has much more advanced optimizations, and actually a lot of those optimizations apply to JRuby very well. We switch over to that compiler, run our same JRuby code, and we can see some improvement. How much improvement? Well, here's our JRuby numbers again. We've got our JRuby at 3 seconds per iteration here. We have our JRuby with Invoke Dynamic at 1.33 seconds here. Now, if we combine Invoke Dynamic, the JVM dynamic language support, with this new Graal compiler, now it starts to get serious at this point. This is very close now to writing this in Java itself, in a statically typed language, and compiling it down. Just a little bit slower than what that would be. So we're going to see more of this in the future. We're really excited about the work that's being done on the JVM. All right, so getting started with JRuby. We have jruby.org, and you can certainly go and just download a tarball and unpack it. Really, the only prerequisite here is that you have some JVM, some JDK installed. You can go to OpenJDK, you can download Oracle's JDK, there's ones from IBM. So whatever platform you're on, it should be easy to go and just install OpenJDK or another VM. Then install JRuby. We generally recommend using a Ruby switcher or Ruby installer like RVM. There is a Docker image out there that we're maintaining. A lot of the Linux systems have a system package that you can install for JRuby, so there's plenty of ways to get JRuby on your system. But as I mentioned, you can also just unpack the tarball, put it in your path, and run it. And as long as there's a JVM and you've got your JRuby, it'll work. And that's really about it. That's all there is to running JRuby. There's nothing to compile per platform. There's no source to download. You just RVM install JRuby, have a JVM, and you're up and going. And there we are. So we have our JRuby running. Do a few calls to JVM Library, the Java Lang runtime class here, get the available processors, which is shown as 8 on my system, how much memory I had free, and so on. You can call into Java libraries from IRB or from any Ruby code anytime you want. A few notes about gems and paths. Most of the Ruby switchers will keep your gems separate. Generally, gems get installed into an isolated location. But just so you know, it's not really good to share across implementations or across versions even. They won't be compatible a lot of the time. Sometimes system packages may install in a global location, so keep an eye on that as well. Also, we've had various issues. A lot of libraries, a lot of applications have a .ruby version file that every time you go into the directory, it will switch back to CRuby. So if you're testing with JRuby, this can be kind of annoying too. So keep an eye on that. And now I need to put a little caveat in here. One of our issues is startup time. This is a difficult problem for us. In CRuby, pretty much everything that runs at startup is already compiled to native code. In JRuby, we have to give it to the JVM will optimize it, and then eventually it will start to run fast. But that leads to a startup time that isn't great. So 3, 4, 5 times as slow for small commands. If you're starting up something like Rails that launches a whole second process, it can be even worse. And unfortunately, this is not really our fault. Here's an example of running one of these commands repeatedly in the same process, in the same JVM. It speeds up significantly. It's not that JRuby's slow, it's just the JVM takes a while to get going. So one of the things that we've added is a --dev flag that you can use in your local environment. This will turn off some of our optimizations, tweak the JVM a little bit so it starts up and warms up faster, and this can be 30–40% reduction. So if you're looking at using JRuby, definitely remember this flag to try and keep your startup time down a little bit. Finally, getting help. We have our GitHub project, JRuby. We are monitoring 3 different chat rooms at this point. We have an IRC channel, we have our Gitter channel, and we're also starting to monitor a matrix channel that we set up. And of course, there's a mailing list with not a whole lot of traffic. Seems like mailing lists are not super popular these days. All right, so let's get into something more practical here than a Mandelbrot set. Why would you want to run JRuby on Rails? Well, JRuby has actually run Rails since version 1 something, 1.2, 1.2.3, something like that. So we've had this stuff working for a long time. And there are many JRuby on Rails applications out there. Oftentimes an application gets too big or has too many users, and the only option is to add more hardware, spend more money on it, or possibly move to JRuby. So there's a bunch of people who migrate to JRuby just to be able to scale their application a bit more with the same hardware. Again, it's a Rails application, so you get benefit of the JVM, all the libraries, and all the other languages on the platform, but still writing just normal Ruby in a normal Rails app. Configuration differences are pretty minimal here. So here we have the Ruby Rhino being swapped in for the Mini Racer gem, just to have our own JavaScript library that uses an implementation called Rhino on the JVM. Remove a few things from the development group that aren't designed for JRuby. These are designed for a Ruby that can fork, and we don't have that. Not really important since you're not spinning up multiple workers in this case. The database configuration, usually the only thing you have to do is point it at an actual port, since most of the JVM database stuff doesn't support Unix socket connections. But that's about it. Swapping the database YAML over is pretty trivial. And then depending on how you want to deploy it, setting up how many threads you want rather than how many workers you want. You'll generally use a single process with JRuby and just have a number of Puma threads that are behind the scenes handling it. Here's passing results for Rails 5.2. 4 nines, almost 5 nines of the Rails tests actually pass on JRuby, so pretty much everything that you're going to do in Rails should work just fine. The remaining failures are goofy things like this, where I don't know if anybody really needs down to the microsecond precision on your date time, but probably not going to be a concern for most of your applications. We have our own active record adapters that work on the JVM and work across all platforms. So if you want to access a Microsoft SQL server from Linux, it'll just work. If you want to access IBM DB2 from Mac OS, it'll just work. So whatever database you're using, whatever platform you want, it'll all run well. Rails 6, we are 3 nines here. We're still working on a few of these suites. There's a couple of them that don't run properly, a couple minor things that are just about test runs, but looking pretty solid here. And our active record support for 6.0, which is active record JDBC 60.x, is also pretty close. Not too many excludes. Most of the things are working well. All right, so let's move on and actually run a Rails app and see how it looks. So we generally recommend running with Puma. That's the server that we've kind of blessed as the best option for the Ruby style deployment. Most of the other deployment tools that you're used to will just work with JRuby. They're really just sending code out there and starting stuff up. Heroku has built-in support for JRuby and so on. Now, one thing to note is that the JVM loves to just use all the memory that it possibly can in your system, unless you tell it not to. So there's some JVM flags that you can pass through JRuby or put in an environment variable to keep it down to a size that they're comfortable with. Here I'm setting it to 500 meg. A small Rails app, you can probably choke it down closer to 150, 200 megabytes, and that will be your entire site that will run on that one process. So scaling up, now this is where it starts to get interesting. This is kind of the classic Rails problem on CRuby. Because we don't have real parallel threads, you need to spin up more processes. And even with copy on write, even with heap compression tricks, we're still going to be duplicating a lot of in-memory state. All of the data that has to be read out of the database to prime the application, any data that needs to be kept in memory. So there's going to be some duplication. You're going to waste memory by having all these processes. JRuby is definitely a great answer to this. You have a single process. You throw as many connections, as many threads as you want at it, and it will handle your entire site in that one process. So single process, the GC works great, will never be a problem for you. It really scales up extremely well. One anecdotal story, this is an anonymous story because they didn't want to tell what company it was that got these great gains out of JRuby. It's a very large Rails application. So this was running 40 extra large instances on EC2. Anybody who uses EC2 and looks at their bill knows how much this costs, lots of money. They were running 40 unicorn workers on each one of these servers. So they were eating these machines up, trying to get enough scaling. This is the sort of story that we're doing everything we can. We're spending more and more money, more and more instances, and still just not getting the performance that we need out of this app. They were getting out of this only like 100,000, 150,000 requests per minute on this, not even second request per minute, with 50 to 75 millisecond response time. And at this point, they decided that they needed to look at another option. So they started taking this application. They did, I think they said it was about 2 weeks worth of work for a small team to do the migration over, swap out some libraries. They dropped that down to 10 extra large instances. So cut their EC2 costs down to 25% of what they were, and consistently doing better than 150,000 requests with that setup, with even lower response times, just by making a move to JRuby, saving 75% of the hosting costs. That's pretty good. That's real money. All right, so what about optimizing for Rails? How do we get JRuby to run this stuff? This is really the most important metric for any Ruby implementation. Like maybe you can run Mandelbrot fast. Maybe you can emulate a Nintendo Entertainment System really fast. But if you can't run Rails fast, it's not going to really help most Rubyists. It's a very difficult framework to optimize. For years, we were able to run it. We were able to beat MRI and all the other benchmarks, and Rails was still slower. It still did not work well enough. So we have just recently, in the past year and a half, convincingly started to see JRuby run Rails applications faster, and sometimes much faster than CRuby. So first of all, we'll move up from Mandelbrot to just a baseline Rails application. This is just the blog post, application. Simple blog. I was running it on real hardware here, so this is an extra large instance on EC2. I'm running everything on the same machine, so it's not quite so scientific, but I threw a couple different implementations at this. I show CRuby and JRuby here. The truffle Ruby numbers were so low that I think something's broken, and so we won't go into that. They're still working hard on this, and they will admit that they're a year and a half away from production ready. So if you want to look into truffle Ruby on your own, go for it. So lots of different drivers, lots of different numbers. Depending on which tool we use to drive the benchmark, we'd get different results. So we're kind of using a combination of AB and WRK and Siege to get a general view of what performance looks like. Okay, so here we have just the basic example of a simple blog post application. This is doing a full view of one of those blog posts. So going all the way to the database, getting the result out, rendering it, and printing it out. And here, it's faster than CRuby. It's not a crazy application. Most of the time here is spent going out to the database, dealing with the sockets and the connections coming in. But at least what we have here, we are running faster on just a simple, single model view here. So let's look at something a little bit more intense, more of a real world application. We actually have rubygems.org. The site is a Rails application, a very complicated set of tools all wired together. So we got rubygems.org to run on JRuby to be a more realistic benchmark. In this case, it was my partner, Tom Enabo, was the one who did most of this benchmarking on his machine, an i7, 16 gig of memory, pretty much just standard production mode rubygems.org, except we weren't running with SSL. There were some issues getting it configured, and we didn't want to mess with certificates and stuff. Puma, as I mentioned, we usually recommend that for JRuby. Again, a single machine, and pretty much everything worked. There were some pieces that weren't quite functional, like uploading gems, but it's just a matter of getting those other pieces stitched in and working properly. So let's take a look at 3 different configurations here. So this is MRI with a single worker, a single instance, single process, versus MRI in a clustered mode with multiple workers, at least as many workers as necessary to use all the cores in the system. And I think actually we threw it up to like 20, so it would match up with JRuby's 20 threads. And so then JRuby with a Puma single process, but using threads rather than processes to scale this up. So here is CRuby. As you see, we throw more concurrent threads at it, more concurrent connections. It really doesn't change. You're still only getting 1 CPU's worth of performance out of this system. If we switch over to the clustered CRuby, which is how you would get threaded performance, scale out across the cores, we see that it goes up until it's, starts to tail off around 4 concurrent threads on it's an 8 hyper-threaded core system, but a 4 real core system. And then once we get up to about 8, then really the scaling stops, like you'd expect. We're using the whole system. Now, unfortunately, with this setup, with just the rubygems.org running on CRuby with workers, once we started getting above about 18 concurrent requests, we started to get errors from the client. So the benchmark driver was seeing requests getting 400s and 500s and whatnot, and things were starting to fail for us. So bit of problem there. Not sure if that's CRuby or concurrent Puma or how the workers were, but it's something that is worth mentioning. And then, of course, if we throw JRuby at this, we get our slight performance bump per core that we're actually using, and we scale right up just like you'd expect with the number of cores in the system. And no errors, of course. So we were able to take this up even beyond this, up to 100 concurrent, 200 concurrent requests, and it was still scale up just fine. So what about memory usage? This, I mentioned that the JVM tends to use as much memory as possible, but we're also going to be comparing with multiple CRuby processes that share some things through copy on write, but maybe not all of the things that are running inside the application. So after one run of this benchmark, we were looking at about 3 gig for the CRuby processes to run rubygems.org versus about 1.2 gig for JRuby. And now we each grow over time. We stretch our legs and things warm up and things get cached. JRuby continues to grow up until after about 10 or 11 runs of the benchmark, and then it pretty much just levels off. It doesn't grow anymore. We're at about 1.5 gig. CRuby's at 3.5 gig at this point, and it still continued to seem to go up, and we're not sure when it would ever stop growing. I know there's folks that have to periodically kill workers because they will continue to grow. That should generally not be an issue with JRuby. Now, again, it's all not perfect here. We do have a bit of a warm-up curve here. So this is after multiple iterations of a short benchmark. It takes a little while for JRuby itself to optimize, and then the JVM to optimize. Folks that put this stuff into production usually will just have a worker script that runs through, makes sure that all the key views in the system are up and going, and you don't see too much of this warm-up in a typical setting then. So takeaways from the scaling stuff. Generally, once you get up to more than 4 or 5 concurrent requests, JRuby will use quite a bit less memory. And of course, if you keep going and go up to 100 instances and you want to get 100-way concurrency on it, it's going to have some problems if you're trying to scale that up in CRuby. JRuby itself should be able to go up to as many concurrent requests as you need on a given system. It's been much more memory stable over time. It grows a little bit from the time you start it up until you're done benchmarking stuff, but then it levels off pretty nicely. And it generally makes better use of the CPU. We're getting more requests per second out of each of those cores on any given system. Okay, so the last major section here, hopefully this has got some folks interested in what it takes to, and what you can get out of moving to JRuby. What does it take to actually do this migration? So the use case that I'm going to go over quick is Discourse, another very large Rails application with lots of moving parts, lots of libraries. This is over 500 gems that are involved if you go follow all the dependencies through, 250,000 lines of Ruby code just in Discourse itself, I believe. And it has no official JRuby support. So this is a good challenge for us to try and get it working. So step one, you run JRuby lint. We have a JRuby lint gem out there that basically will do a couple things for you. You'll install this gem, switch into your application, run JRLint. The first thing that you'll start to see is that if there are gems that we know we can't support in your gem file, we will try to suggest alternatives to them. So here for the for the fast XOR gem, which is a C extension for CRuby to take two strings and XOR the bytes together, there is a pure Ruby gem that works just fine called Exorcist. Same thing. These suggestions are all actually sourced from our wiki page. So we have a wiki that lists all of the known C extension alternatives for JRuby. If you find one that has an alternative and it's not on here, just follow the same format and the tool will pick it up. So the gem name and then whatever the suggestions, that's what shows up in JRLint. It'll show pieces of code that are sometimes threading concerns. For example, if you're doing plus equals or equals, even in CRuby, these aren't guaranteed to be atomic and safe across threads. So we will mention that maybe you should take a look at this. Maybe you should look at wrapping it with a lock. But anyway, it's possibly questionable code. And then we do scan for some unsupported features like object space. Each object is only partially supported in JRuby. And then, of course, if we see calls to fork somewhere in your application code, we'll let you know that that's not going to work in JRuby either. So that kind of gets you a first pass on the application. What does it take to make that first step to move to JRuby? So step two here is then find those C extensions and replace them. If there are suggestions, obviously you can just swap them in. There will very frequently be things gems that we don't know about, gems that don't have an equivalent yet. For example, bybug, which is very specific to CRuby internals. Maybe you can just ignore this. So try to install it, doesn't work, the C extension isn't there, but it turns out it's just a development dependency. It's not something you need. You can just say only on platform Ruby and not on platform JRuby. So as far as actually replacing it then, if you do need this library and it's not an external dependency or not an extraneous library, the first option would be just to use something pure Ruby. So this is basically some of the code from the Exorcist pure Ruby gem, and it works just fine. You can throw Ruby code at it. JRuby optimizes pretty well. Now, if it is really serious performance critical code, sometimes the Ruby code in JRuby will be a little slower than a C extension, but oftentimes it's not that big a deal, especially if it's just doing some network hit or something in the database. Pure Ruby is probably just going to be fine on JRuby. Option two for swapping out a C extension would be to use FFI. So FFI provides a way that you can write pure Ruby code that loads up a C library, binds functions, takes the functions out of that library, and makes them available as Ruby calls. Simple little example here. This is actually from the 0MQ library for Ruby, all of Ruby, and it's FFI based. So we take our module, we extend FFI library, so we have all of the FFI stuff available. We specify the name of the library that we want to load in, and it will do the typical lib searching on any given system. And then we just tell the FFI system we want to pull in the 0MQ stir error function. Okay, here we go. Load FMI method, load specific DLL. Attach function, here's the name of it. Here is what the input parameters are, and there's a couple of standard names for these, int and long and so on, like C names. What sort of return value we're getting out of it. There's also the blocking true there, you notice. We can tell the JVM whether this is going to be a call that requires extra handling, but usually you don't need to worry about that. You're making a quick call down to a library. And then it's just a Ruby call at that point. Then you're actually calling from Ruby through the JVM down into this C library. And this code will work on regular CRuby, on JRuby, on Truffle Ruby, on Rubinius. It'll work on everybody. So this is definitely what we recommend if you need a C library. So option 3, if it's not a native library or it's a C extension that's just a bunch of C code basically, is see if there's a JVM library that does it. All the libraries on the JVM, written in Java or Scala, Kotlin, Clojure, whatever, can be called from Ruby code in JRuby. So find the library you need, wrap it with a little bit of Ruby niceness, or a little bit of Ruby syntax, and you've got your library working on JRuby. The example I show here is MiniRacer. So MiniRacer, as I mentioned earlier, is a C extension that wraps the V8 JavaScript engine for running and compiling JavaScript from within Ruby code. But it turns out that there's a library for the JVM called J2V8, which does the same thing. It wraps the V8 library, it has a build of V8 built into it, and since it's on the JVM, we can just call it with regular Ruby code. So a little snippet here, we pull in the J2V8 jar file, which is how Java packages are distributed. We import the V8 class, and we create a V8 runtime. And that's all there is to it. Nothing to compile, no magic to get C extensions working. We just pull in this library and call it from Ruby code. Load the Java library at the top. There's our import of the V8 class, create the runtime, and execute the script. And this will all work just fine. So we use this to get Discourse up and working too. So option 4 here is to write your own extension. For some libraries, they're not actually calling out to a C library. What they're doing is basically just bundling a bunch of C code for performance. The example here is the OJ library. Whoops. The OJ library, which is a fast JSON parser and generator. It's about 20,000 lines of C code. It calls out to no other libraries. So our only option here is really to port this library, and that's what Tom has been doing. Here is a little code snippet from the JRuby version of OJ. We are implementing the strict load method here, and we bind it, and all of this stuff happens automatically behind the scenes. It doesn't take too much work to port this stuff. C and Java are fairly similar. Once you know where the JRuby APIs are, it goes pretty fast. There's our OJ module up at the top. There is our defining of the strict load method, and JRuby will just automatically bind this to the class. So a little C extension summary here. So your 4 major options, if you can't ignore the gem, just replace it with Ruby is what we first recommend. Use FFI if it's a C library. Use a JVM library if there's one that works for you, and that's often the best option. Or write your own JRuby extension or hire someone to do it. And that's it. There's really no step 3 here. Once you have your C extension swapped out, once you've dealt with things like forking, if your application bundles and starts up, it's probably going to run. Any issues after that, maybe bugs in JRuby, maybe bugs in a library that wasn't tested on JRuby, let us know. And again, like I say, all the deploying options are out there, plus everything from the JVM world. So let's wrap up here. So some future work that we're doing on JRuby, we're still trying to decide this 2.6 or 2.7. If anyone has a strong opinion, please let us know about that. In order to deal with the startup time, we are looking at doing a full native compilation of JRuby so that it boots up as fast as CRuby. That will hopefully be coming up in the next 6 months or so. And then other JVM features that are coming up, having real fibers on the JVM. There'll be a new built-in FFI support for the JVM. All these new JITs and garbage collectors and all this stuff is really cool. Ooh, jeez. So JRuby on Rails futures, I mentioned that Rails 6 is working. We're going to get the active record support out for it real soon. And basically, we're here if you need us. If you want to migrate to JRuby, want to try it out, just contact us, get onto our chat channels, and let us know how it goes. Wanted to thank all the many companies that use JRuby now or have used JRuby in the past. We've been really thrilled to help companies like Square and Bank Simple get off the ground and get stuff scaling up. Folks like IBM have actual commercial products that ship JRuby in them. BBC News runs all of their election results for all the UK elections through a JRuby application. So there's a lot of cool stuff out there. My favorite, I always have to tell this one, the Allen Telescope Array that's part of the SETI project, the Search for Extraterrestrial Intelligence. The Allen Telescope Array out in California actually uses JRuby to coordinate the telescopes. I mean, there's a bunch of C++ and assembly that actually runs this stuff, but a Ruby application on JRuby that is aiming telescopes and looking for aliens. That's pretty cool. So as always, help wanted. Stop by, let us know if you have some time to assist. Try out JRuby. Let us know how it goes. I'm going to be here all day tomorrow as well, so anyone who wants to sit down and play with it, I'll be here. And that's all I got. Thank you.
Thank you very much. Okay, we are kind of running out of time, so we are open for one question.
One question.
Just one question.
Hi. Since this morning I was talking about Ruby with types. So is there any way, any plan to JRuby support types check?
So we will support whatever CRuby does, first off. So as that settles down and we see how that is implemented, we will implement the same things. Luckily, we have the same parser as CRuby, essentially just a port to the JVM. So any changes at that level, we should be able to support easily enough. We're just going to wait and see how that goes. I am interested in possibly the performance aspects of it. Maybe we can do some more speculative guesses at optimization. But for the most part, the JVM optimizes stuff pretty well already, even without the types.
Okay, great. Thank you very much for your sharing.